Engineered Controls International Incorporated, the manufacturer of RegO products, presents an introduction to LP gas internal valve. Safe and efficient transfer of LP gas requires trained personnel and properly designed installations. The ideal installation reduces the likelihood of accidents and keeps operating efficiency at a maximum. Internal valves are incorporated into many installations to help achieve these ideal results. The internal valve serves as a primary shutoff valve. When installed directly into a container, the seating mechanism is above the container connection. The valve is designed so that damage to parts exterior to the container or mating flange will not prevent effective seating of the valve. The valve also allows maximum flow when opened, providing faster unloading and more efficient pump performance. Internal valves are used in a variety of installations: bulk storage tanks, bulk transport trucks, and bobtail delivery trucks. They can also be used in small capacity pumping stations, industrial storage tanks, and inline installations. There are two types of internal valves: manual valves, opened by means of an operating handle or pneumatic actuator, and automatic valves, better known as Flomatic valves, which operate using pressure from the pump. While both valves perform similar functions, their design and operation is very different. The manual internal valve is designed to open and close using an operating handle, or if one has been installed, a pneumatic actuator. Their movement rotates a cam, which allows you to open and close the valve by controlling the position of the stem. There are two springs: a closing spring, which keeps a downward closing force on the stem, and an excess flow spring, which supplies the upward force to open the poppet. The poppet, which controls flow through the valve, contains both a seat disc to seal with the body and a seat disc to seal with the stem. In a typical installation, the manual internal valve is installed in the bottom of a container. Gas flows freely through the holes in the strainer and the open areas of the upper body. In the valve's closed position, gas fills all areas above the poppet. The poppet is held against the valve body by the force of the closing spring and the force created by the gas pressure above the poppet, which is greater than the pressure below the poppet. To open the valve, the cam is turned to the halfway position by rotating the operating handle. This overcomes the downward force from the closing spring and pushes the stem upward away from the poppet's seat disc. In this position, a flow path in the midsection of the stem allows gas to quickly bleed downstream through the poppet. The flow continues until the gas pressure is equal above and below the poppet. When the pressure is equalized, the compressed excess flow spring will force the poppet upward, breaking the seal with the body. To complete opening the valve, the cam is turned the remaining distance, pushing the stem upward and allowing the poppet to move to its fully opened position. The poppet will not open unless the valve outlet piping is closed, allowing the outlet pressure to equalize tank pressure. When a demand for gas downstream is created, the valve provides maximum flow and optimum flow rates. The entire opening action takes about 15 seconds. The valve must be opened before starting a pump. When opening the valve, if the cam is moved directly to the full open position instead of the midpoint, the gas bleeds more slowly, taking longer to equalize the pressure and longer for the valve to open. To close an opened valve, rotate the cam away from the main poppet. The force from the closing spring pushes the poppet to the fully closed position. The seats create a gas-tight seal with the body and the stem to stop the flow of gas. Manual internal valves incorporate an excess flow feature, which closes the valve should the flow of gas increase beyond a predetermined point. Increased flow through the valve causes a higher than normal pressure drop across the poppet. When the pressure drop reaches a specific point, it overcomes the preset load of the excess flow spring. The poppet then moves to the closed position. When this occurs, the pump should be stopped immediately and the nearest downstream valve closed. The poppet seals with the valve body, but not with the stem, which remains in the open position. Gas bleeds slowly downstream until the outlet pressure again reaches tank pressure. To reopen the valve more quickly, the cam should be rotated to the mid position, allowing maximum bleed through the flow path of the stem and faster pressure equalization. As soon as pressure below the poppet equals the pressure above the poppet, the excess flow spring will push the poppet to its open position. The handle should then be moved back to the fully open position, allowing maximum flow. All manual internal valves, regardless of type, are designed with the same principles, operating easily using either the handle or a pneumatic actuator. The design of the Flomatic valve, however, is quite different. It operates automatically, opening when the pump is on and closing when the pump is turned off. The key components of the Flomatic valve include a 1/4 inch line, which supplies differential pressure from the pump's discharge connection to move the stem. The stem assembly controls the piston, which opens and closes the valve. The piston has two seals, one with the valve body and one with the stem. An X-ring guides the piston during its movement. An indicator slot shows the position of the stem. A horizontal reading, as seen here, indicates the stem is in the closed position. A vertical reading would indicate it is open. A spring provides the closing force on the piston and stem. In a typical installation, the Flomatic is installed in the bottom of the container with the pump mounted directly to the outlet. A 1/4 inch line connects the discharge side of the pump with the Flomatic via a 3-way valve, which is normally left open. The 3-way valve is also connected to the suction side of the pump. The gas moves freely through the strainer. When the Flomatic is closed, gas flows through an opening in the piston and fills the area above it. The Flomatic's built-in needle valve allows you to control the flow of gas through a priming channel to downstream of the piston. This valve is normally left in the open position, which is 1 1/2 turns, but can be closed to isolate the downstream side of the valve during repair and maintenance. Gas flows through the opened priming channel until the pressure below the piston is equal to the container or tank pressure above the piston. When the pump is turned on, pressure downstream of the pump increases. This is referred to as differential pressure, which is the pressure generated by the pump above tank pressure. This forces gas through the 1/4 inch line into the area under the stem assembly. When the pressure under the stem creates a force that overcomes the force of the spring, the stem moves upward. This usually requires an opening force of about 20 psig differential pressure. As the stem rises, the seal between the stem and the piston is opened, allowing gas to flow between the areas above and below the piston. The force below the stem pushes the stem and piston upward to their open position, moving the visual indicator to its vertical position. The opening process takes approximately 10 to 15 seconds. Gas flows through the opened valve with minimum pressure drop and large flow capacities. When the pump is turned off, gas is no longer forced through the 1/4 inch line. The gas under the stem bleeds off through an orifice in the body. As the pressure under the stem decreases down to approximately 8 pounds per square inch, the force of the spring pushes the piston to its closed position. With the Flomatic valve, the opening and closing operation is fully automatic. To close the Flomatic from a remote location, the 3-way valve can be actuated. This closes the 1/4 inch line running from the outlet of the pump and opens a line running to the inlet of the pump. The pump suction pulls the gas from under the stem into the pump. This quickly reduces the gas pressure under the stem allowing the piston to close rapidly. A Flomatic does not incorporate an excess flow valve, but does have an excess flow feature. When the flow downstream of the pump surges beyond normal operating conditions, the pressure downstream of the pump drops. This reduces the pressure through the 1/4 inch line, allowing the spring to close the piston. The pump should be stopped immediately and the nearest downstream valve closed. When the pressure below the piston equalizes the container pressure above the piston, the pump can be restarted. Differential pressure will build back to its opening point, and the piston will return to the open position. Both the manual internal valve and the Flomatic are designed to ensure easy installation and maximum operating efficiency. A number of accessories are available to enhance their operation. Many manual internal valves accommodate thermal latches. They hold the operating lever in the open position during normal operation and return it to the closed position if exposed to fire or extreme heat in excess of 212 degrees Fahrenheit. These latches may also connect to a cable that allows closing the valve from remote locations. Pneumatic actuators provide a convenient means of opening and closing manual internal valves from a remote location. They operate using an air or nitrogen source. Remote thermal releases provide remote closure and thermal protection required by some pressure vessel codes. Remote thermal releases allow you to close the manual internal valve by pulling a cable connected to the release and will trip the operating lever to the closed position automatically if exposed to fire or extreme heat in excess of 212 degrees Fahrenheit. Remote cable controls allow operation of manual internal valves from remote locations and can provide remote closure from various locations. Internal valves manufactured by Engineered Controls International are designed with the same quality engineering that goes into all RegO products. So whether your application is for storage, transport, or pumping stations, for LP gas or anhydrous ammonia, there is a RegO ECII internal valve to fit your needs. Available in sizes ranging from 1 1/4 inch threaded valves to 4-inch flanged valves. From 30 to 600 gallons of propane per minute closing flow. From manually actuated valves to completely automatic valves. Whatever the application, ECII has a valve for you.